not all we're going to do today, though. Okay, I want to review you on standard form. Okay, standard form we did in section 1, and it was just y equals ax squared plus bx plus c, where we had to, when we graphed it, we found the opposite of b over 2a for the x-intercept, plugged it in for the y coordinate, and our c value was our y-intercept. Okay, and what we want to do today is we just want to write the equation in standard form. All right, so what we're going to be doing is we're going to take in vertex form and intercept form, we're going to change it into standard form. Okay, because there's always benefits to each type of form. Okay, if I want to write the equation in standard form, here's what I can do. Okay, I want it to be in the form y equals ax squared plus bx plus c. So I'm going to say y equals, all I'm going to do here is FOIL. First, outer, inner, and last. Take x times x is x squared, x times 3 is 3x, 4 times x is 4x, and 4 times 3 is 12. So y must equal x squared plus 7x plus 12. And as you can see, now if we were going to graph this, we could do the opposite of b over 2a and proceed on from there. In this form, though, we could have done our x-intercepts and then found the vertex that way. Okay, so there's benefits from being in each form. If it says write the equation in standard form, this is the equation in standard form. All right, and we know how to graph both ways. Okay, but there's other benefits to each type of equation. All right, so once again, okay, if we wanted to graph it right now, we could. Our a value is -4, so we know it's going to be facing downward. It'll be a max value, very steep parabola, and our x-intercepts are at 1 and -3. That's what we learned today. However, sometimes it's easier to do things in standard form. So what I can do is this. It says write the equation in standard form. That means I need y equals ax squared plus bx plus c. Okay, I just want the numbers, no parentheses. So I'm going to go ahead and start distributing. I know that in multiplication you multiply straight across from left to right. So I'm going to distribute my -4 first. -4x plus 4 is what I get when I distribute the -4. I still have my x plus 3 back here. Now what I have is a FOIL. So I'm going to take -4x times x, -4x squared, -4x times 3, minus 12x, 4 times x, and finally 4 times 3. So y must equal -4x squared, I'm going to add my like terms, minus 8x plus 12. Okay, and now it's in standard form. And we know how to graph in standard form. We take the opposite of b over 2a, find the x coordinate, plug it in to find the y coordinate. Our axis of symmetry lies on that line, and finally our y-intercept is 12. All right, so there's benefits of both ways. I'm going to say it again. Now, you need to know how to do it in both formats, okay? But if you ever are stuck, you can always change it to standard form and work through what we did the other day. Okay? This one happens to be in vertex form. Now, these are what we did yesterday, actually. So the vertex would be at -2, 3, and so on, and we could complete it from there. However, the directions say write the equation in standard form. All right, now let me remind you, x plus 2 squared minus 3 is the same as this. X plus 2 times x plus 2 minus 3. This is not x squared plus 4. That's no. Do not do that. That's incorrect. Okay? What it is this. This is what it's saying. Okay? So what I'm going to do is I'm going to say y equals, I'm going to go ahead and FOIL. X times x is x squared. X times 2 is 2x. 2 times x is another 2x. And then 2 times 2 is 4. And I still have this -3 right here. I'm just going to tack him right on the end because nothing happened to him. All right, now I'm going to add my like terms. I have x squared plus 4x plus 1. So now, as you can see, I do have this standard form equation that I also know how to graph, and I also know what it looks like. Okay, the a value still tells you the same thing. It's always still in front on both of them. The vertex is at -2, -3. Should be -3. Okay. And in this one, we could find the x coordinate of the vertex by the opposite of b over 2a. Okay, so you get the same thing that way. All right, and so as you can see, there's a lot of different things you can do with both forms. Okay, this is called standard form, where there's no parentheses and you can't really tell anything right off the bat. All right, so let's do one with a fraction here, and it says f of x this time. That's just function notation, nothing really changes. Okay, I'm going to keep it f of x over here. I just need to make this into f of x equals ax squared plus bx plus c. And so what I'm going to do is I'm going to rewrite it how I know it should be. This is actually two terms. Okay, and what I'm going to do is I'm going to actually just FOIL it first. So I'm going to save myself a little fraction work. 1/2 times x squared minus 2x minus 2x plus 4 minus 5. Okay, nothing happens to that minus 5. Please remember to bring them down because that's a very common mistake. So what I have here is 1/2 times x squared minus 4x plus 4 minus 5. And finally, when I distribute this 1/2, I have f of x equals 1/2 x squared. Make sure your x squared is in the numerator, minus 2x plus 2 minus 5. Okay, so f of x equals 1/2 x squared minus 2x minus 3. Okay, and this will be in standard form. In both, okay, it tells me it's going to be a little bit wider. It's going to open up. I'll have a minimum value. Same thing here. Okay, it tells the same thing. It tells me on this one the vertex should be at 2, -5. Down here it's going to be a little more work, but we can still find the vertex by taking the opposite of b over 2a. All right, so one more time, you need to know how to do both forms.